You know me, I always encourage people to save energy.
Hello Electroboom, how are you? You sell merchandises of full bridge rectifiers. So today I will be simulating your own rectifier, full bridge rectifier in my simulation window, and let's see how it works. First of all, let me build the simulation, build the circuit, then I am coming back to you. This is our scope. This is the input voltage. Here you can see this is total is a raw AC voltage of a very good sine curve, but it is our rectified voltage, which is 120 volt DC. It is outputting a DC voltage, and there is a big hand of the capacitor that we added here. This capacitor, the value of this capacitor, I selected the value of this capacitor as 100 microfarads. So what if I reduce its capacitance to only 10 microfarads? Let's also see what happens now. Now after running the simulation, if I click on the scope, it is just the same because there is no resistance in the circuit. The load is only capacitive load. That's why it is not having any ripple. The capacitance or the capacitor is handling everything. Now if along with this capacitor I add a series resistance of, let's say, 1000 ohm, so then we will be seeing some ripples. So this is a capacitor with series resistance. Here it is not shown in the circuit, but as you have seen in the block set, I have selected the series resistance of 1000 or 1 kilo ohms. So the capacitor, there should be some ripples with the capacitor of 10 microfarads only. So let's see what happens now. And as I said, there is a ripple voltage because of the capacitance, resistance at the very beginning. See, thus the capacitor has handled everything. Now what if instead of a series resistance I connect let it be 0? I don't want, because the resistance, if in series, it is not going to show the ripples in the whole graph. So what I have to do, let me redraw the circuit. Now what I have done, I have removed the capacitor to see some ripples on the graph. So I have removed the capacitor from its place and added a resistor, and the capacitor is in parallel with the resistor, so that the capacitor so first of all, select the resistance value to 1000 ohms. So after selecting it to 1000 ohms, let's see if it is selected or not correctly. Yes, it is 1000 ohms, and the capacitor's value to be 10 to the power minus 6 farad is 10 to the power minus 6 farad is around 1 microfarad. Yes, so let's say for simplicity I take it as 100 microfarads. Let's see how the graph looks like. So first of all, we have to run the simulation. After running this simulation, let's double tap on the scope to see what is the result. Now you can see very clearly that the ripples around the resistance. So this ripples, there are very small ripples around 120 or something like this. The ripples are only because of the capacitor is handling. Otherwise, if there was no capacitor, let's say I open circuit this portion, so here nothing is connected. For simplicity, I am removing the wires also. So if there is no capacitor connected, then if you see what is happening, you will be amazed. This is the scope now. It is rectifying the voltage, AC voltage, but the AC voltage here is rectified to DC, but it is having very big ripples. See, these are okay. This is an inverted one. See, for this part it is down like as the input voltage. Let's say for this part it is down as like as the input voltage. For this part it is inverted. Why it is inverted? Because I have connected the voltmeter or the voltage sensor the opposite way to the polarity. I know there is no polarity for AC, but there is polarity for DC, obviously. And for this part, the negative cycle of the AC, this is the zero line of the AC, and below this is the negative cycle of the AC. This is always negative. See, the cycles are always negative, no positive cycle. So this is not AC. This is half AC, and this is not even half AC. This is DC. This is DC with no capacitance, or a very bad DC. So this is our full bridge rectifier. This is our full bridge rectifier as in the merchandise or the t-shirts of Electroboom. Thank you for watching. Meet you in the next video. Goodbye.